Microphone check. 1 2 1 2. It's your boy, the network, in the building. Back with another live stream. Shout out to Pete in the Discord server over there. If you guys are not joined to my Discord server, let me give you guys an invite so y'all can join. Do I even have it up over here? Episode number 101. 101 live streams we've been here. Y'all know how we did on these other streams, right? We was using that 101 Labs book, and now we're doing 100. We've done 101 streams. Didn't think I'd make it this far. Now, I ain't gonna say I didn't think I'd make it this far. I just never really seen myself starting a YouTube channel and doing live streams on it. So I guess that's how long I've been doing this for. Anyway, we are going to be using Boson Netsim again today. Y'all know I'm becoming a real fan of this software here to help us learn about routing protocols and just networking in general and stuff like that. Let me get what was I going to get for y'all? I was going to pull something up and I forgot what it was. Oh, the Discord server. That's what it was. I'm pulling up the wrong. That's Slack right there. What am I doing? Oh, man, Discord. There it is right here. Anyway, give it some time for some people to tune in and stuff like that. Typically, I stream Monday through Thursday, 8 p.m. Eastern Standard Time. We've been using multiple applications and workbooks to study for the Encore exam. I don't have to take that exam. I just like doing this stuff for fun and refreshing my knowledge on those topics. Plus, they introduce a bunch of new topics. But I do have to take an elective exam. And I'm going to take the NRC, which is also known as the Advanced Routing and Switching exam. I forgot what the EN stands for. But here is the invite to the Discord server. You'll see it in the chat over there. Appreciate y'all for tuning in. Again, we'll just give it a couple more minutes for some people to tune in and stuff like that. What we got on the news today: a new bank fraud malware called Vultur, that's V as in Victor, ULTUR, infects thousands of devices. Screen sharing, courtesy of VNC, mirrors device screens to attack controlled servers. Isn't that crazy? That was one thing that used to just scare me. Just wait until they start being able to hack into Android devices, man, because you can root them, and then a lot of people keep their information on their phone. I got my girl, she has all of her stuff that is on her phone. I keep telling her, and it keeps telling her she's running out of space. She need to back it up somewhere, like either to the Google Drive or Photos or something. But all of it is stored locally on her phone. So if somebody gets, hacks into that, then they can take all of her stuff, right? Great work, brother. Greetings from Paris, France. Appreciate you, Cone Fine. Appreciate you for tuning in. Tuned in all the way from France, man. I appreciate that, man. I really appreciate that. Never been to France. Never been to Paris. I've never been to Europe, to be honest with you. I've only been to, where have I traveled in? I don't think I've traveled anywhere in the East Hemisphere or the Western Hemisphere. East, rather. Yeah, South America, Canada. I haven't been anywhere besides them two. And obviously the United States, a bunch of places in the United States. But anyways, Vultur recently detected Android malware, some spread through the Google Play Store, uses a novel way to supercharge the harvesting of login credentials from more than 100 banking and cryptocurrency applications. I keep my banking information saved on my, I don't keep the login cred saved on the phone. I don't keep it saved on the phone, but I do believe I have it. I ain't gonna tell y'all all that. What am I thinking? But anyways, the malware, which researchers from Amsterdam-based security firm Threat Fabric are calling Vultur, is among the first Android threats to record a device screen whenever one of the targeted apps is opened. Vultur uses a real implementation of VNC. Y'all know what VNC is, right? Type VNC is basically like remote desktop software that you can use to, remote into other devices and stuff like that. They also do like screen mirroring, really. And the VNC screen sharing application to mirror the screen of the infected device to an attack controlled server. researchers with threat fabric said. So basically, you log it into your device, log it into your, say your bank account. They use Type or VNC or this application, Voltor, which works like VNC and just mirrors your screen and takes that recording and dumps it onto a server so they can see you type the information, which is weird because if you're typing, usually you'll see little dots, right? But I don't know, maybe they got some kind of keylogger, tied up into that as well. But either way, they found that as a threat, and that's really scary, man. Voltor, so y'all look out for that. That is crazy, man. Crazy. We got Dear Tech IT in the building from Togo. Hello, bro. I appreciate you for tuning in. Shout out to Dear Tech IT. Today we're just going to be working with simple Ospf lab, configuring single area Ospf with Boson Netsim. The good folks at Boson have gifted me a free copy, and I just use my channel to kind of demonstrate their application and stuff like that. And once I get to 5,000 subscribers, which my goal was to get to that by the end of the summer, I will give a free copy of that. So make sure you hit that like button and make sure you subscribe to this channel, man. So I will be doing that giveaway soon. We're almost there, y'all. We're almost there. So the objective of this lab is to configure the network using Ospf for a single area. All Ospf routers will be in area 0. And this is the topology we're going to be working with. I guess I could zoom in for y'all if y'all want to take a closer look at that. Bloop. Bloop. Right. There it is right there. They call this side right here pod 1. This side right here, that's pod 1. And this side over here, well, I'm going to scoot over to this side over here. You guessed it, pod 2. What the heck? You see, in these applications, I need to stop using this one right here. This is the, y'all know my bruh sound effect app. Got all these ads and shit on it now. So I can't hit the bruh button at will. It's all good though. So here we're going to just pretty much set up Ospf, I believe, on just pod 1. And then they're going to be asking us a bunch of questions and stuff like that. I'll go ahead and get started. I don't think there's a lot of people that's tuning in today. We got Pete S in the building. Good morning. Appreciate you for tuning in. I forgot you all the way tuned in from Australia, right? So I'm like, good morning. What are you talking about? It's about to be nighttime, man. Oh, yeah, that's right. I got viewers from all around the world. I got to keep reminding myself about that. But anyways, lab task. Task 1. We're just going to be working with Ospf, single area Ospf with Boson Netsim. We'll get back to that one-on-one labs book. I think that one-on-one labs book is a little advanced, man. I need to definitely step my game up before I crack that book open again. But we'll get back into it soon. Configure Ospf on P1R1, which is this guy right here, P1R2, which is this guy right here, and P1R3 using a process ID of 1. All interfaces, including loopbacks, should be placed in area 0. So that's the first task they want us to do. We'll start with P1R1. Y'all know what Ospf. Let's do a brief overview or review of Ospf. So Ospf, we know, is a routing protocol, right? Stands for Open Shortest Path First. Uses what's called the Dijkstra's algorithm. It uses this mathematical computation to, guess what? Find the shortest path first, right? And believe it or not, the SPF algorithm, which stands for shortest path first, is the same algorithm that they use in GPSs, right? To calculate the fast. So when you put in an address in Google Maps, right? It runs the SPF algorithm underneath the application to find the fastest path to your destination, right? The same thing works with routers and switches that run Ospf, and that's basically how Ospf works. And we use that to share routes to other routers and vice versa. And but the first thing is we need to become neighbors first, and I'll show you guys how to do that. What I wanted to do though, shout out to what's his name, Jeremy Stretch at packetlife.net. Again, he's got these cheat sheets that I've been using and stuff like that. They've been around for a long time. But if you go to packetlife.net, there's a link that says cheat sheets, or a menu that says cheat sheets, and it gives you basic review, or basically like a cheat sheet for a bunch of topics for the CCNA exam, and they're also applicable to CCNP. So let me bring up those notes real quick for Ospf so we can do a couple more fun facts. I guess I'll start with task 1 when my stuff loads up over there. So they want us to put the router in Ospf. Well, it says here, all interfaces, including loopbacks, should be placed in area 0. What is area 0 known as? You guys know? I guess pop quiz, real quick pop quiz. Not pop quiz of the day, because y'all know I like to ask y'all questions, right? So the way we enable OSPF, we just type in router and then OSPF and then the process number, right? We can put a number, any number between 1 through 65,535. Process number they asked us to do was what? 1. We'll do 1. That puts us in router config mode, right? And then we do what's called network statements to advertise where we want to, what interfaces will be participating in OSPF. Well, we got, how many interfaces before we do that, let's see what interfaces we got. Do show IP interface brief, and we'll exclude the unassigned so we can filter it down to just those interfaces there. So we got 2 networks. We got the 192.168.1.0 network, and that's 192.168.1.0, and then the 10.100.100.0 network. But we don't know the subnet masks, so we need to verify that as well. Let's do a show Pete's favorite command, show protocols, right? I hope that works on here. It does. So we got a /28 network, and then we got a /24 network there. Now, what I'd like to do is we can advertise OSPF on all of our interfaces by just typing in the network statement, right? We type in network, and we can just do 0.0.0.0, 255.255.255.255. Yeah, like that. And then we say the area we want to put it in. They said what? They should be placed in area 0, and Diane Foster got it correct. She said backbone. That's correct. The backbone area. Area 0 is known as the backbone area, right? So we're going to put all the interfaces, these interfaces right here, into area 0 by just typing area 0 like that. And when we do this right here, oops, that's area 1 or 10. We do this right here. We're going to advertise OSPF on all of our networks when we do it this way. Now, real quick, I already did the lab, so they don't want us to do it this way. This is kind of like a cheat way, a way to cheat, right? By putting OSPF on all of our networks. They want it specifically for these specific networks. So we can't do it this way. We're going to do network, and then there's a network statement that will cover everything in this interface or that network, which is /24. So in this case, we're going to do 10.100.100.0, and then the subnet mask of /24. But we don't work with subnet mask. I believe we work wildcard bits, right? Yep. So it's the reverse of the subnet mask, right? So instead of 255.255.0, we do 0.255.255.255, right? I hope that makes sense, right? So 255.255, right? So here we go. I'll explain real quick. Instead of a subnet mask, 255.255.255.0, right? Which is what? /24 insider notation. We do the reverse of that. See the 3 255s and a 0? We do 0.255.255.255. That is the wildcard bits that we're working with. Now we can type in area 0, and that's going to put any interface in this network to participate in OSPF, right? OSPF process 1. Now let's do another network statement to do the what? The 192.168 network, but our subnet mask is going to be not that, but the reverse of that. Remember? So same thing. Network. What is it? 192.168.1.0 subnet mask of, I forgot what that one is. It's what, 248? No, 255.240. So we got to do reverse of that, which would be, notice we got OSPF coming up already. So we already got one neighbor. Work.0.0. I believe it's 15. Y'all correct me if I'm wrong, but I believe the network should be 15. Area 0. That should put the other interface into OSPF. So I think what happened here is we already have a neighbor. Since we're only going to configure OSPF on this side right here, pod 1, we made a neighbor with this guy right here. So that interface right there, which is, it says on FA00. So we confirm that FA00. How can we do that? We can do this. We can do this. Let's take a look at the cable connections, current connections. Is that it right there? Yeah. So that interface right there is, bloop, where's that? P1R1 FA00. So yes, that was this interface right here. So we should theoretically We're not going to get another neighbor yet because I think this guy is not participating in Ospf yet. So he was in Ospf, and that's why these two are now neighbors. That's what this indicates right here. Adjacency change, process 1. That is the interface we learned it from. Or that is the interface we learned it from. This is the IP address for it, for the neighbor. Because ours was 1.33. And I think that should be it, right? Yeah, it should be it. So let's we want to do OSPF on this guy right here as well. Let's go to enable mode, show. Let's look at our interfaces and what networks are on here. Show IP interface brief, exclude, unassign. We got the 192.168.1.0, but let's do protocol so we can see all of our. Shout out to Pete for that command. I'm keep shouting you out for that, man, because I love this command because it gives us a subnet mask right here, right? So we got to do 00015 for the subnet mask. Am I correct? Yeah, Pete, you said it right. 15. That's correct. That's the subnet mask I was looking for, or the wildcard bits I was looking for. 15. Thank you, Pete. Ale Coelho says for a /24. What you mean? So for a /24. The wildcard bits will be 0.255. Yeah, 0.255. If that's what you mean, right? So anyway, we need to do. I think we only need one subnet map. One wildcard bits. Sorry, one network statement for this. So remember, we said process ID of 1. Again, router OSPF process ID of 1. Question mark real quick, right? So it's between any number between 1 through 65,535. They wanted specifically 1. We do another network statement to cover these interfaces here, right? That's going to be the serial interface and that interface right there to become a neighbor. So it should be 15 as well, the last octet for the wildcard bits. So I believe 192.168.1.0. So 000.15 area 0, and we should theoretically become a neighbor. These two guys right here should become a neighbor. So if we did this correctly, we should see a syslog message come up on here. Let's get on our knees, pray to the network gods, because I'm not seeing no message yet. Come on, Boson. Come on, router 2. My bruh app over here. Y'all hit me with that like button, man. Y'all hit me with my likes, man. Y'all know this helps out when y'all hit that like button. Pete said 000.255. Yeah, that's the wildcard bits for a. Yes, my bad. I said it wrong. Pete got it correct. So that's 4/24. That is the wildcard bits. I was saying it wrong. We got Zai in the building. Hello, family. Appreciate you for tuning in. I don't see this guy becoming a neighbor yet. Let's see what happened. What we do wrong here. Let's do a show IP. Let me see. He should get 2 neighbors. Let's take a look at him. Show IP OSPF neighbor. We got some troubleshooting already to do here. 2.0 network, which I believe was. Let's see. Show IP OSPF. No, let's do this. Show IP interface brief. Exclude, unassign. Let's see what we got. He became a neighbor with a 2.0 network. That's crazy. He did not become a neighbor with this guy yet. Or maybe he did. I don't know. But he should have became a neighbor with this one. Let's see. 192.168.1.0. 00015. Right? Yeah, 00015 area 0. OSPF 1. And then did we put that network statement over here? We did. 192.168.1.0 area 0. Yeah, so that should have became a neighbor. I don't know what happened there. Let's move on and we'll take a look at it later, including loopbacks. All right, we'll take a look at that later. So let's do the next one. We'll have to do some troubleshooting there. Enable, show IP interface brief, and see what interfaces we got here. This is the 1.50, so we'll do show protocol so we can see our subnet mask, show protocols. So /28. So this should be 1.0 1.0 and then 00015. So same thing. So these two become neighbors. Let's go to global config mode. We'll say router OSPF, same thing, right? So router OSPF1 network, and then we'll say 192.168.1.0 00015 area 0, right? And then these two should become neighbors. If not, then we definitely got some troubleshooting to do here. And if we do get it wrong, remember there's solution guide at the bottom, and we can hit grade lab, and that's also going to tell us what we're missing. So OSPF takes it's a little, I'm gonna say, yeah, it's slower than EIGRP, but faster than BGP. I think we should have gotten a neighbor by now though. Let's take a look at P1R2. Let's see. I don't see anything coming up just yet. Now again, we could have just used a blanketed statement, and that would have made everybody a neighbor. But he became a neighbor with somebody. You said, bro, what to do? We got S Move in the building. We got Monostar in the building. Appreciate you for tuning in. Pete said 192.168.1.0/28 is network 0 with hosts 1 through 15. You need 192.168.1.32. Oh, yes, that is correct. So you need to put the correct network address. That's what it is. Okay, so I got the subnet correct, but I've got the wrong, I got the wildcard bits correct, but not the right network statement. So we need to fix those network statements for sure. I appreciate y'all for finding that. So let's see. What do we got here? This guy is 34. So he, like you said, is in the .32 network. That's the reason why that's not coming up. This guy is in the that's going to be every 16 networks, right? So 16, 32. This is going to be in the 48 network, right? Right? But I thought it would have been 1.0. Oh, that's a totally different subnet. Yes, you're right, guys. So we need to fix a whole bunch of network statements. We need to fix, and this is why I like going back to the fundamentals. So let's do this. Let's go back to this guy. Global config mode, right? And let's get rid of the 1.0 network. So let's do that. Router OSPF1, and we're gonna get rid of this guy right here, right? Because remember, they work in subnets. So just like what everybody's saying there, you need to put the correct network address for the /28 subnet. Otherwise, do it as Al Cone said, or Ale and Cone said, which was, what did you guys say? Because I'm skipping everything here. Oh, you wanted more specific than that. Because the first config, wild mask machines, only just the first byte. Yes. So, and like what Pete said, that's what helped me out right there. When you said that 1.0/28 network is 0 through 15. So it doesn't count. It's not going to count that one interface. Let's see. It's not going to count that interface or this interface right here. 1.0 is just going to be, like you said, networks 1 or hosts 1 through 15 because our wildcard bits are too specific. So we need to do a statement like network 192.168.1.32/15 and 1.48/15. Or we could just do one network statement, right? Yes, we could just do one and just do .32. So .32 and then 00015 area 0. That should bring up a network somewhere. Let's go to P1R1 and fix that other one. Which one was that? That was, we need to get rid of that over here and make it 1.32 as well. We need to get that. We need to fix that right there. 1.32 as well. So we'll go to router OSPF1, get rid of this, and do a network 192.168.1.32 is what we said. The 32 network, because it's every 16 networks is the block. Yeah. So 1.32.000.15 area 0, and this is why they came up with these funky IP addresses to kind of trick you, because this is another network. I would have thought 1.0 would have covered this. So good catch, you guys. I appreciate y'all for tuning in. This is why I rock with y'all. Let's see here. Zaya said yes. Okay, good. So we should theoretically see a neighbor somewhere in here, right? He's 1.32. There's 1.32. What else do we need to fix? Was that too specific? The 1.32 network, area 0. There they go right there. There go the message right there. So now we have a neighbor. Okay, so now we need to do the same thing. Did we do anything specific over there? We probably need to fix P1R3. What network did we put? We put that blanketed statement there. So the 1.50 network. So 1.50 is in what network? It's every 16 network. So this is the .48 network right here. So we need to make this 1.48, right? I use that same network statement, trying to be lazy. Network, and they got me with those funky IP addresses. So 1.68.1. What's that? 1.48 we said, right? Yeah, 1.50 is actually in the 48.0 network. So 48 and then 000.15 like that. Area 0. Get on our knees, pray to the network gods. Yeah, multiple ways. I'm not sure what Boson wants for this one. Yeah, exactly. He said .48. Zaya got it correct. There's .48 network. So yeah, I was just putting 1.0 thinking it was going to get everything in the 1.0 network. That's not going to work. Let's wait for the syslog message to let us know we had a neighbor. Please become a neighbor. Come on, buddy. And my phone just died. So no more bruhs for y'all. Let's see here. P1R3. That was the correct network statement, right? So yeah, 1.0. Yep, there it is, right? Nope. We need to fix this guy's side then. Let's see. We need to put another network statement. Is that what it is on this one? 48. We need to do 148 over here. That's what it is. That's what it is. So we need to put this exact network statement on P1R2. That makes sense? Good subnet mask review for me here. So let's get rid of. Let's look at how our network statement looks like so far. Do show run, and then section Ospf. Y'all see how? And then 1.32. So we need to do 148 in this network as well. So now we do network 192.168.1.48. Same thing that Zaya said. So we put that same network statement on. I was pointing at the screen like y'all can see it. What the fuck is wrong with me? Putting that network statement on here and here. This is the .48 network, so it'll put those two interfaces in to participate in OSPF, right? 000.15 area 0. What's wrong with me, man? Oh man, I think I'm delirious, man. Let's see here. Get on our knees, pray to the network gods. Hope for a syslog message to let us know it's participating in OSPF. Cue the Jeopardy theme song. Are we coming up? Don't look like it just yet. There you go, right there. There you go. So now now these two are participating in OSPF. These two are participating in OSPF. And then when we put that one first statement, it made these two become OSPF neighbors. So now we look at our routing table, which I should have showed y'all before we made these interfaces participate in OSPF. Y'all would have seen the difference between a routing table that does not have OSPF routes versus one that does have one. Maybe we could look at this one to see. I don't know. We'll see. So now, what was the questions here? I think they got some questions they wanted to answer here. So question 2, do two routers require the same OSPF process ID in order for a neighbor relationship to be established? Do two routers require the same OSPF process ID in order for a neighbor relationship to be established? So remember when we did this right here? The router, where is it? We said router OSPF 1, right? This number right here is the process ID. It can be any number between 1 through 65, 535, right? So what they're asking here is if you have another router that has an interface and participating in OSPF, does it have to be in the same process? Do they have to have the same process IDs? So mine is OSPF1. Does the other guy have to be OSPF1 for us to become neighbors? The question is, the answer is, Zaya got it correct. She said no, they don't have to be the same process ID. So I can be in router OSPF1, or my interface could be in router OSPF1. The other one can be in OSPF 69. I don't know why I chose that number, but he can be in OSPF 69, and we'll still become neighbors, right? Don't get this confused with EIGRP. Two routers that are participating in EIGRP, or their interfaces are participating in EIGRP, that AS number needs to be the same. So you'll have like router EIGRP and then 10. Guess what? The other interface, the other router, he needs to be an OSPF or EIGRP AS number 10 as well. They have to match. Now, OSPF, they don't have to match. Don't get those confused. Matter of fact, I had a job interview. The guy asked me that same exact question. So that's just something that when I first started studying for this stuff, I usually get confused. I was like, I thought they had to be the same. No, OSPF, they don't have to be the same. EIGRP, that last number, the router OSPF, that number that come right here, need to be the same for EIGRP. So just don't get those two confused. Ale Coelho said no as well. That's correct. Both of y'all got it correct. Al Coelho, you initially said yes, but you changed your answer. But it's all good though. Yeah, so no, they don't have to match OSPF. The process IDs don't have to match. Question 3 says, on P1R1, which is this guy right here, how many OSPF routes exist? Well, we do a what? Show IP OSPF, and we'll see. Show IP OSPF. No, I'm sorry. Show IP routes. And then we can filter it down to, we'll see a whole bunch of routes here, right? We got our local, we got our connected, we got our OSPFs, as indicated by these little O's right here, right? Well, we can filter it down to just OSPF with show IP OSPF. Show IP route, and then question mark, you'll see we can filter it down to static routes, BGP, connected, EIGRP. Well, guess what we came to do? OSPF, right? OSPF, right? Y'all hit me with that like button, man. Y'all hit me with that like button, so that way we'll have more people watching and stuff like that, and it'll be a better learning environment. So that way I'm not putting the wrong network statement, and I can look over and see the correct answers from you guys, because y'all always get me straight, man. So we got one. Here's how we can check, right? When we do show IP OSPF, we'll see a legend at the top. It tells you what each one of these are. The L means it's a local route. C means connected route. S is static. Well, guess what we're looking for? We're looking for an O, which indicates it's an OSPF route. Well, how many are there? There are 1, 2. Sorry. Let's see. Let's scroll up. So yeah, that's it. 1, 2, 3, 4, 5. We got 5 OSPF routes. Question 4 says, what is the administrative distance of the OSPF routes? The administrative distance is, first one that answer it gets a bruh whenever I power up my phone. Zaya said, I like your style. Appreciate that. I appreciate that, man. Y'all know, like, I try to keep it funky, man. Like, anybody can learn this stuff. If I can learn it and become a network engineer, then y'all can do the same thing too, man. And believe me, it can be a lucrative field too. So, like, when I first got in IT, I was doing just like desktop support and help desk, and, tech support and stuff like that. Wouldn't really make that much money until I actually became an engineer and stuff like that. So, anybody know what the administrative distance is for OSPF? Default. Now you can change it. What is the default administrative distance for OSPF? Joe Rockhead got it correct, and he got it before you, Zaya. I'm sorry, but you got to be quick on the draw. Yes, it's 110, and it's indicated if you look at the show IP. The routing table. This 110 right here lets us know it's the administrative distance. 110. This right here is the metric, right? So this is an OSPF route. The administrative distance is 110. What's the administrative distance? Blah, 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 blah. It's like we got 2 ways to get to a city, right? Y'all know I like comparing networking to roads and highways, right? We can have 2 ways to get to a city, right? And they are equal to each other, right? 2 ways to get there. And we use the administrative distance as a tiebreaker. Basically what it is. So we have a way to get to LA, route A, and we got route B that takes us also to LA as well. Well, we're going to pick the one that has the lowest administrative distance, right? And the reason why we'll get different administrative distance is because we can learn a route from OSPF, which would be what? 110, like Zaya and Rockhead said, or we can learn a static route that takes us to a specific route. And that administrative distance will be what? 1, right? Yeah, 1, I believe. No? Yeah, 1. And guess what? We're going to pick the one that has the lower administrative distance, 1. So we'll pick a static route or over an OSPF route. So administrative distance, or AD, is known as our tiebreaker, right? Or is used as a tiebreaker. Next question says, on P1R1, verify the new AD, which is this guy right here. Well, we already did that. Well, this lets us know the AD is 110. Another way we can check is what? Just show protocols, I believe. What? Not show protocols. Show IP protocols? Lets us know the administrative distance? Yes, right there. So we do show IP protocols. That gives us the administrative distances that we learned for different routes. 110, 110, 110, 110, just like Zaya and Joe Rocket said. So task 2, use the show IP OSPF command. Y'all got to know y'all show commands. Know your show. I'm gonna trademark that. Know your show. Which is why I say that. There's different ways to get to an answer, right? You can do show run and then spacebar, 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 spacebar until you see all the answers and stuff like that. But if you know the different show commands to give us these answers, because when you take these exams, they give you show command output, and you gotta kind of interpret it that way, right? So this one right here uses the show IP OSPF command. They want us to answer those questions using that output, right? So in this case, on P1R1, we do show IP OSPF, and they said use the output to answer the following questions, just like you would in an exam. What is the router ID? The router ID is, we go to the top and we'll see ID is 192.168.1.1. That's router ID, right? Why did the router select this router ID? Y'all mean to tell y'all, y'all want to pop quiz again? Morningstar said, I was all the way off. BGP 80 administrative distance is 20. Hey, Morningstar, it is all good. Once you start seeing them all the time, you'll start picking them up and remember them. I bet you after this stream, you're going to remember OSPF. I remember OSPF because it has the letter O, right? So does 110. 110 has, an O at the end of it, or a 0 at the end of it. But don't get that confused with 120. 120 is RIP. BGP is 20. I guess they all have 0, so that's not a good way to remember it. You'll see them. You'll see them, and you'll start to remember the Morningstar. There's only about, I guess, 7 administrative distances that are default. 10, something like that. I don't remember. We got PS said, Linux King. What you mean by that? What you mean? We got, keep it techie in the building. Appreciate you for tuning in, man. We got the Linux King in the building, man. Appreciate you for tuning in. Keep it techie. Josh from Keep It Techie. If y'all want to learn about like Linux and stuff like that, y'all make sure y'all join his channel. He does a lot of stuff on the different Linux OSs and different commands and stuff like that. Diane Foster got it correct. The lowest IP address. Actually, I think you're wrong on this one, Diane. I hate to point you out like this, but I believe it's the highest IP address. Highest active, well, to be more specific, it's the highest loopback address. The highest loopback address. Correct me if I'm wrong, you guys. And that's why I like discussing too. Maybe I am wrong, and maybe you're right. But I believe it's the highest loopback IP address, the highest active loopback address. So we have, let's say we got some IP. Let's see what he got. They said our IP address, our router ID was 192.168.1.1, right? Let's see what interfaces we have on here, right? Show IP interface brief. And we'll exclude unassigned, so we'll see. We got 3 IP addresses here. We got this guy, and this guy, right? And he said our router ID is 192.168.1.1, right? If I could fucking this button, man, mouse. All right, he said our router ID is 192.168.1.1. Well, guess what? That is not the highest IP address, right? I mean, not the lowest one. The lowest one would have theoretically been the 10. See there? So it's not the lowest one. You see that? So that leaves us with 2 IP addresses that can tell us what our router ID is going to be. We got this one right here, 192.168.1.33, and this one right here, 192.168.1.1, right? Well, guess what? This one is a higher IP address, right? Higher than this guy right here, 1.1. Well, guess what? This guy is a serial interface, and this guy is a loopback, which is why I said it's the highest loopback. And Paul B just said it. It's the highest loopback. If no loopback, it will be the highest up IP address. Exactly, Pete. I mean, Paul. I keep saying Pete because Pete usually chimes in with the correct answer. But yes, Paul got it correct. It's the highest loopback address. You see that? Y'all hit me with that like button, man. And subscribe to your boy, man. Typically, I stream Monday through Thursday, 8 p.m. Eastern Standard Time, if I cancel or something like that, or if I got like a bonus stream on the weekend, like I ain't got shit to do, then I'll hit you up on the Discord server and let y'all know. But yeah, Paul B got it correct. It's the highest loopback. If there's no loopback address, it'll be the highest up IP address. So that is the reason why this became our router ID for OSPF, right? Next question said, how many times has the router executed shortest path first, or SPF? Y'all know what that is, right? So SPF is the algorithm. It stands for shortest path first, as you can see right there, like y'all dumb. I said it like y'all ain't know. I just didn't say it. The SPF is the algorithm that OSPF uses to find the shortest path to get to a destination, right? We need to know how to get to the, I don't know, the 192.168.1.0 network. It's going to run the SPF algorithm, this mathematical computation invented by this German physicist. I believe he was a physicist. I can't remember, but his name was Dijkstra, and it uses that mathematical computation to figure out the fastest way to get there. And believe it or not, like I said in the beginning of the stream, this is the same algorithm that GPS is used to find the quickest destination to get to wherever you need to get to, right? So when you run in Google Maps or your GPS on your phone or whatever, it runs the SPF algorithm to find the quickest destination to, get you to Rachel's Steakhouse or whatever. But where's my mind at right now, man? Diane said it correct. Yeah, thank you. Highest loopback. So yes, highest loopback. If there's one not available, it's the highest up IP address. So yeah, it's a good discussion though. I sometimes I like it when I'm wrong, or I like it when you guys are wrong. It's good for us to discuss. That way we all are on the same page and we'll remember this stuff, right? So not like I was trying to call you like, dang, you got it wrong, nothing like that. It's just this is how we remember things, right? So how many times has the router executed SPF? Well, it tells us right here using this command, and it says right over, I think it's at the bottom somewhere. Right there. No, I just seen it. There it is right there. SPF algorithm executed 12 times. That's cool, right? And that's a fun fact for y'all, though, about the SPF algorithm, right? So it's been executed 12 times to find the quickest destination or to pull up these fast routes and stuff like that, right? Or routes to the fastest way to get somewhere. How many interfaces are in Area 0? Well, using show IP OSPF, we'll get that as well. It says it in plain English, I believe somewhere in the middle. There it is right there. Number of interfaces in this area, 2. Couldn't get any simpler than that, right? How many areas does this router participate in? Well, usually the other areas will be at the bottom of this output, right? We only use the area 0, and there's only one area right there, which is the backbone area, which is just like what who said it earlier? Diane said it correct. So yeah, the backbone area is also known as area 0, or area 0 is also known as backbone area. So I believe final task. No, we got two more OSPF. Shit, damn. I think we got like 3 more OSPF commands that they really want us to dissect this shit. Whatever. All right, so this is how we're gonna learn it, right? P1R1, display OSPF neighbor information. So we go to P1R1, we're already on there. We type in show IP OSPF neighbor, right? Simple. Can't get any simpler than that, right? And they want us to answer the question using the output. How many neighbors does P1R1 have? Well, it says right here, we got 1 neighbor, and that's his ID, and we got 2 neighbor, and that's his ID. And we can even look at the topology, physically see this guy right here. He's got that guy as a neighbor and that guy as a neighbor. So we have 2 neighbors there, right? This cloud right here is not our neighbor, so that's not participating in OSPF. That's a frame relay cloud, so don't worry about that guy right there. What does the full state indicate? Full right there. See, it says full right there. Full right there. Well, there's different states that it needs to get to before we become neighbors. It starts in the down state, then it goes into the init state, and then there's like a whole bunch of them, right? I'll probably pull up a chart, and we'll see what the different states is. But we don't become fully adjacent with neighbors until it's in the full state, right? And that's what it is. That's what that indicates, that we became fully adjacent with another neighbor. What was it he said? He said you can also run show IP protocols to see what interfaces are running OSPF. Yes, that's another command that we could do. Show IP protocols. That's another one I like. Did we do that? No, we did show IP OSPF. Yeah, we could do show IP protocols as well. That's also going to show not just OSPF, but it'll show us everything. So if we're running OSPF, RIP on here, God forbid we're running that. God forbid we're running that routing protocol, but it'll show us under that as well. If we're running BGP, it'll show us all the routing protocols we're running on there. So yeah, shout out to Paul for that one. Which neighbor on the FA00 interface is the designated router? Well, that's indicated by this DR right here. It don't mean doctor. It don't mean Dominican Republic. No, it means the designated router. Who's the designated router? He's the guy that everybody reports to on the OSPF network, like the OSPF neighbor. So like we got these routers right here, right? We said this guy's a neighbor, this guy's a neighbor, and this guy's a neighbor. So essentially this is kind of like well, minus this guy. We'll leave him out from now. We'll be prejudiced. These three right here are kind of like in an OSPF network. They're participating with each other, right? Well, one of these guys will become a a designated router. We all share routes and stuff like that. That's who keeps the main database. We all report to the designated router. Who's the designated router on this segment? This guy right here. But this is a point-to-point network, so it's pointless. Bars. This guy right here. So basically, he said the neighbor ID with 2.1 is the designated router. So he is going to get all his routes and stuff like that from this guy right here. That guy keeps like the main database. We all report to him, but it's really just him. I don't think he's going to get his information from him. So on this segment, we can see who's the designated router, but that's not what they ask us right now. So why is there no DR? And that's what it is. That's what's going to ask us right now. Why is there no DR or backup designated router on P1R1's serial 0 interface right here? Why is there no designated router right there or backup designated router? Well, goddamn it, there's only two of us here. It's just like, why should we have a vice president and a president if there's only just two of us? There's no other people to govern here. That's the reason why. But to be more specific, I believe it's because it's a point-to-point network. And this is what I like about OSPF, about Boson is we don't really know the answers, or if I don't know what the hell I'm talking about, I could always scroll to the bottom and it'll give us in plain English what answer they're looking for. So we go to task 3, question D, right? So 3D. We go to task 3D, and it says here, there is no DR BDR on the serial interface because DR and BDR elections do not take place on serial point-to-point networks, which is just like what I said. So this right here is a point-to-point network. There's only two of us, a vice president and president. Why do we need to elect who is going to be the designated router if just two of us? We don't have anybody else to govern here. That's the reason why. So that's just my analogy of how to explain that. So task 4. Y'all got any questions or anything so far? Or y'all let me know if I'm like confusing y'all or if I'm making it more confusing. Like I said, this is just a quick overview. Like this is for single area OSPF. Now we can do more areas, and that's also known as multiple area or multi-area OSPF. Right now we're just working with single area. So this area right here is the backbone area, is area 0. We can make this as area 59, and then this is area 69, whatever the case may be, and that would be considered multiple area. Right now we're just working with one area, area 0. So y'all make sure y'all hit that subscribe button. Again, I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. And where are we at here? Oh yeah, so that was that question right there. So next question, use the show IP OSPF database command. We only got, let's see, 3 questions here and then a gazillion questions there, and then we'll call it a night, right? So they want to know how many link state advertisement types are shown. All right, well, let's go to P1R1 and find out. This guy right here, we just do show IP OSPF, and I believe it's database, which is just what it said, right? And we'll see there's different types of area LSA types. LSAs are like, it's kind of like, I forgot who said it. It was maybe a CBT Nuggets trainer that said they're kind of like baseball cards. Excuse me, baseball cards. We're trading routes and stuff like that, and we say we're missing this route. Can you give me this? Well, this lets us know what routes we learned them from, what routes we have, and where we learned them from, and stuff like that, right? But there's different types of LSAs. I'm not going to get too deep into them because this will be a really, really long ass video and it'll be a deep subject, right? But anyways, just to break it down, this is one type right here, the router link state type. This is one LSA type. So we got one here. And then we got another one right here, the netlink state. I believe that's a type, if I'm not mistaken, that's a type 3 LSA. Y'all correct me if I'm wrong. I can't remember. But this is a type 1 LSA. And I believe this is a type 3 LSA. I don't remember. Y'all correct me if I'm wrong. But there's two basically types of LSAs, right? So we have link IDs. We have the advertising router. How long, we not how long we became neighbors, but how long we got this information for. What else? It's pretty much all that gives us. What else they want to ask us here? What type of router generates a router link LSA? Well, guess what? This type right here, which I believe is type 1, router link LSAs, right? What else? I guess that's it for task 4, the LSA types. Again, I want to say, how many types are there? There's type 1, 2, 3, 4, 5. Is there type 6? There's 7. I want to say there's about 11 LSA types, if I'm not mistaken. But for the CCNA, you'll probably need to know only about router LSA types 1, 3, 5, and 7. But there's like 11 of them. So Joe Rocket said 3. Yes, I think you're right. So I think this is type 3 LSAs, and this is the type 1 LSA up here and type 3 LSAs down here at the bottom, right? So we got 2 types, but there's the first one is type 1, and this is type 3 LSAs, right? And no, I have not really gotten them really memorized just yet. Again, there's I want to say there's about 11 of them, if I'm not mistaken. Joe Rocket said, wait, LSA is a type 2, I believe. Network LSA is type 2. Yeah, maybe. I don't know. I can't remember. But I know router link, the first one is definitely type 1. Netlink, I'm not sure. If anybody else wants to chime in and let us know. That's why I like having these discussions. It helps me remember and stuff. So use the show IP. This is the last show command, and we're going to call it a night. And we're going to round it up to just about the hour like we normally do, starting at 8 and finishing at 9. We just got questions A through N. All right, so on P1R1, this guy right here. Display the OSPF interface information. Use this output to answer the following questions. How many interfaces are configured for OSPF? So we do show IP OSPF, and then do we have to type the specific interface? No. So you just type in interface, and it tells you all the interfaces that are participating in OSPF. This area says how many are configured for OSPF. Well, we scroll back to the top. Let me scroll up some so y'all can see the output better. We got FA00 right there is participating in OSPF. We scroll down some and we got 000 also participating in OSPF. Now, this is what I don't like about Boson. Sorry, Boson, but please let me stay to where I need to stay in the CLI next version. So we got 000. It looks like on this interface, on this router right here, we only got 2, which is what we said, right? We got that serial interface and this guy right here, which is the FA00. Interface participating in OSPF. So we got 2 that are configured for OSPF. What is the router ID used for every interface? Well, how's that determined? It even says in plain English. For FA00, the router ID is 1.1. Right there. See, it's highlighted right there. For 000, the router ID is 1.1 as well. Right over. See, I hate that. There it is right there. Sorry. Right there. That's the other router ID. So 1.1. C says, how often are hellos sent out? That's also sent to us in plain English. We just pick one. We'll see timer intervals configured right there. How often are hellos sent out? 10. It says it right there. 10. What are hellos? It's something we say to our neighbors, right? Well, guess what? It also works that way in the networking field, or at least in OSPF. When we become neighbors with an OSPF, or at least when we get into the OSPF neighborhood, right? We start walking around and we look for OSPF and we see a neighbor. We say hello, but we say hello every 10 seconds. When the other neighbor says hello to us, then we become neighbors, but it gets a little deeper than that. But we say hello to each other, then we become neighbors, right? Well, we say hello every 10 seconds. That's something that also has to match for us to become neighbors, though. So my timers have to be configured the same thing as, so if I say hello every 10 seconds, the other guy needs to say hello every 10 seconds before we become neighbors. That's a parameter that needs to match. There's several other parameters, but that's one that needs to match. The hello timers. What is P1R1's FA00? Didn't we answer that question already? The fuck? What is P1R1's FA00 address? Oh, the address. That's why. Okay. I didn't answer that question. I'm like, so P1R1 right here, right? He said the FA00 interface right there. His internet address is that right there. But notice it's different from the router ID, right? Because we discussed earlier how it selects the router ID. So even though that's the router ID on the interface, the actual IP address on the interface is configured as 10.100.100.1. So don't get them too confused now. The router ID versus the actual IP address that's on the interface, right? Kevin said the count goes up to 11. Yes, so I was correct. There's 11 LSA types. He said type 6 is obsolete. It's for Ospf for multicast routing. Types 8 and 11 are rare to no usage for Ospf version 2 and version 3. Yes, exactly. Router LSA is type 1, network is type 2. So, yes, appreciate you for timing in with those answers, Kelvin. He said, where was that command at? It was this guy right here. Where was he at? Didn't we run it here? I thought I did. Maybe it was R3. Thought we ran it here. Maybe it was R1. So, the network types were in Ospf database, weren't they? And I thought I ran it on this PC. I mean, this router. There it is right here. So this is actually type 1, just like he said, and I was correct. And then that's, I believe, what he said, type 2? Network's type 2. So netlink. So this is a type 1 LSA, and this is a type 2 LSA, right? Link state advertisements, which gives us different information, and they all different. And I'm not going to get too deep into what each one of them are, because there's, like he said, there's 11 of them, and I haven't even got them memorized just yet. So, what's the next question? He said, what area is the FA00 interface in? We're almost done, y'all. We got question E. We're going to get to N, and we're calling night. The area FA00 is in, FA00 is right here, and the area is right over, where's that? Y'all see it yet? I'm blind here. There it is right there. Area 0. So it's participating in area 0, which is also known as what? The backbone. What is the cost for using the FA00 interface? Cost should be in there as well. And this is why they're making us look at these show commands, right? Because like I said, we can do show run and try to figure out what's configured and stuff like that, but you need to look at these. You see how I'm kind of like, where is the cost and stuff like that, right? It's taking me too long. When you see these show commands very often, you're able to scan it and be like, okay, boom, there go the cost right there. Boom. How many times the LSPF algorithm be ran? And you scroll up and you'll see, boom. So the more you see these show commands, the faster you're able to scan them. And you ain't going to be like me trying to figure out where the hell it's at, trying to, look all slowly and stuff, right? Because when you're taking these like CCNA exam and CCNP exam, they give you show output just like this and ask you questions about it. So, but it ain't going to be as simple as what is the cost? And the cost is right there. So, what is the priority number for FA00 interface? Priority number is right there. There it is right there. 1, right? What is the IP address of the designated router, or DR, right? We said the designated router is the other guy that we get the Ospf database from and who we sync our database with. The IP address is right there. It says right there in parentheses, designated router. His IP address is what? 2.1, which is this guy right here, who is the designated router. We determined that earlier, right? What else is the next one? Sorry, I'm racing through this because I know it's I'm trying to beat the 9 o'clock time. We already right at the hour mark there. What is the IP address of the BDR? What's the BDR? You know what that is? Zaya said type 2, broader are LSA 3. Let me refresh because it says my chat disconnected, y'all. Y'all hit me that like button, man. If y'all like what y'all see, man, we gonna do this very often. He said, no, 4 is ASBR summary, 5 is external, and 7 is NSSA, which is what? Not so stubby area external route. Like I said, there's like he said, there's 11 of them, and I haven't really memorized all of them yet. So I did at one point, and then once I passed the exam, I was like, oh, fucking remember this shit. Remember it later. Now I'm trying to refresh. So, what is? Oh, I haven't even answered that one question yet. What was the question? Yeah, what is the IP address of the BDR? The BDR is the backup designated router. So we determined that this guy is the DR, right? Designated router. Well, guess what? When he goes down, we're going to shift the database to the backup designated router. Who is that? He said he want to know what the interface IP address is. Backup designated is probably going to be this guy. Let's see. Or we might not even have one in this case. I don't think we got a backup. There it is right there. Backup designated router ID is 1.1. Who is that? That is me, this guy right here. So I'm the backup designated router. Whenever this guy goes down, I will become the designated router. So everybody needs to sync their Ospf database with me. Anybody in this that's in this segment rather. But it's a point-to-point network, so it don't even matter. Well, actually this point-to-point network. But anyway, what is P1R1's 000 IP interface? We scroll down some, there's a 000, there's the IP address, 1.33, not to be confused with the router ID, right? So the actual interface IP address is 192.168.1.33, and then the router ID, stamped right here, is 1.1, right? That with me so far? Let me know if I'm confusing y'all, if I'm not making it clear or whatever. Al Coelho got it correct. That's right. BDR stands for Backup Designated Router. P. Teja said, bruh, can you please explain about the ABR brief? ABR brief? ABR is the area border router. So it's a router that's on the border of an area. We only got one area here. It's area 0. So technically, there's not really an area border router until we have another area. So that's what an area border router is. So like, let's come up with a scenario here, right? They said that, I'll scroll up too, right? Oh, no, we don't have the topology on here. So, all right, so this is actually pod 1, and this is actually pod 2. Well, we put these guys right here in area 0, right? I believe these are also in area 0. We can see, but they didn't ask us to touch them. Let's see. Let's just do a enable show IP Ospf. Let's just show protocols. Guess what? These guys are in area 0 as well, right? So it looks like this whole network is in area 0. We can check. Let's check this guy as well. He's probably in area 0. Enable show IP protocols. Yeah, he's in area 0 as well. So this whole network is in area 0. So theoretically, there's no area border router. Now, if we had this in area 0 and that is in area 1, right? All these guys are in area 1. Well, this guy would sit between the borders of area 0, which is over here, and area 1 over here. So he would be considered the area border router because he's on the border of 2 areas, right? It's like I'm sitting right on the proverbial wall, or right in the China wall or whatever, and I have one side of the country over here and one side of the country over here, and I'm right in the middle. I would be considered the area border router because I'm in the middle of 2 areas, if that makes any sense. Right? Correct me if I'm wrong. I hope I don't confuse y'all or anything like that. No BDR in point-to-point? No, because we don't even say who's a designated router in a point-to-point network, Diane. So yes, good question. I like that question there. She asked, is there no border designated route or backup designated router in a point-to-point network? Well, let's see. Let's see. Before we move on to the other questions, real quick. Who did we say our designated router was? On this network right here, 0. Guess what? Notice there's no DR information over here or BDR information over here, right? Because look, remember, this is the point-to-point network, right? The serial, you see that little yellow, the lightning bolt right there, right? That's the serial interface. It says right here, it even says right there, point-to-point is the network type. So this is a point-to-point network. We did not define a designated router, nor did we define a backup designated router. Because why? It is a point-to-point network. So good question. There is no backup designated router or designated router on this network segment right here. I like that question. What was the... we only got like 3 more and then we'll wrap it up. We'll wrap it up then. These guys there. Y'all know what that's from? Anyway, what is the... P1, oh, we already did that one. The serial interface was this right here. That right there. That was the serial interface. That was the IP address. The next question was, what area, there are two more questions. What area is P1R1's serial 00 interface in? Well, we already determined the whole shit is in area 0, right? So right there, serial 00 is in area 0. Bars. Last question. What is the cost for using the serial 00 interface? And it says right there in plain English, cost is 64. And notice that it has a higher cost than this guy. Why? Because it's a serial interface. The higher the interface, or the higher the cost, how do I say? Like, the higher the cost, the slower the bandwidth, the slower the bandwidth on the interfaces. And we all know serial is slower than fast Ethernet. So that's the reason why the cost is a bit higher on that interface there. And I think that's pretty much it, right? That was the end. Y'all got any other questions? I guess we could grade the lab and see what the fuck we got wrong. See what I steered y'all wrong at, what kind of bullshit I was talking. We got a couple X's here. So let's see. You missed one or more commands. We might have either done it not the way they wanted it, or we just might be missing something. Let's see what we're missing here. And that's what I like about Boson Netsim. You click the grade lab button, it tells you, hey, you're missing this, or you fucked this part up, whatever. So shout out to the folks at Boson Netsim for gifting me a copy of this. Again, once I get to 5,000 subscribers, I will be gifting gifting a copy of this application, so y'all can do it along with me on live streams and stuff like that. So make sure y'all subscribe to your boy. We got a missing command here, right there, right here in the red. We're missing that. And what did we do? We used it looked like we used a more specific command. Let's see what the difference is. We put that instead of 000, like that, 0. I did do it wrong. I sure enough did. Yep. So I should have done 0. We needed to care about just the last octet. So that's what I did wrong. I'll fix that in a second. And let's see what the other ones I got wrong on. You see, hold on. This is what I was saying. See, we did a missing command. Didn't I put that initially? See, man, that is the command I put initially, and it said, nah, I don't like that. They wanted a more, we picked a more specific network statement, and we became neighbors with it. That's the one thing I don't like about Boson, is because they tell you, make these area become neighbors, and then you pick your way to fix the problem, but they said, nah, we want it specifically done this way. So that's the reason why I got that wrong. We just got different network statements. We made it work, but they wanted it specifically using that blanketed network statement there. So let's see what we did on the next one. I think we probably got the same thing here. We put 2 extra statements. We could have just done 1.0 to cover the whole thing, which is what I initially did, which is weird. I don't know why it worked, but we'll fix that too. And probably the same thing on this guy. Let's see. We put the 48.0. We could have just done 1.0. And then I did 000-255. That's weird. That's really weird. Whatever. We could have used 1.0 on all of them. 1.0 on this one as well. And the 10.100.0. That's weird. I don't understand it. That's weird. Whatever. Let's fix that. Call it a night. In case this is your first time, make sure you hit the subscribe button. And if I cancel a stream, or if I got an extra stream on the weekend, you're awesome. Thanks for explaining. Appreciate it, P. Teja. We got Diane Foster said, thank you for your questions and stuff like that. That's the Discord server. Silas said, it's just 2 routers in a point-to-point network. No need for DR or BDR. That's correct, Silas. Silas got it correct, too. So that's the reason why they didn't elect a backup designated router or a designated router, because it is right there. It said point-to-point network. So let's fix those network statements and call it a night. P1R1 had, let's do a show, run, section, OSPF, sección. I did it in Spanish. OSPF. We need to get rid of that right there and put it in 1.0. So let's go to global config mode. And I thought I had this 10.100 network there. Oh, we just needed a 0. We don't care about all of them. We just needed a 000-255 is what it was. That's what I need to fix with that one. So network, what I'm thinking, router OSPF 1, and the network statement they wanted was 192.168. But see, this worked. It was just a more specific network statement. They didn't really say, you know, that's the one thing I don't like about Boson Netsim. They want you to fix the problem, and when you fix it, they say, nah, we want you to fix it this way. And they grade you wrong. So that's the reason why I got it wrong there. 168.1.0. And we said what? 000.255, because we don't care about that last octet, area 0. And then we're going to get rid of, we're going to say no network 192.168.1.32 000.15 area 0. And we're going to get rid of the other network statement, which was no network. Y'all see how I'm removing the network statements? You just type in a no, that negates the whole command, right? Network 10.100.100.0 0.255.255.255 areas. If I can spell area, I was about to spell areola. 0, and we put in notice it's going down, right? I'm going down. That's only because we removed that network statement. It was fixed, but they wanted us to fix it a certain way, so let's go ahead and put their band-aid on it. 10.100.100.0. Well, this one I really got wrong because I didn't put the right wildcard mask for this one, so we didn't care about that last octet is what I needed to do, and do area 0. That theoretically should bring it back up. And then we need to put this guy in 1.0 and the other one in 1.0. See, now it's coming. Oh, we got a duplicate IP address. Interesting. We got some troubleshooting to do here. Before we do that, let's fix this guy right here. Let's take a look at his routing statement. So run. So now y'all can see me break it and fix it, which is how you guys learn too, right? So section, when we have a fixed environment like this, it's not really learning. So section Ospf, right? That just filters down. We wanted just a 1.0 statement, which is what I initially had, but they didn't like it. I don't know why. Router Ospf F1, and we're going to negate those two commands that we got there with the no network 192.168.1.32. Get rid of that area 0 and get rid of, notice it's going down as well. And then get rid of the other one, which is .48. That's going down. Network. And now we'll put a blanketed statement, which I did initially, and I don't know why I didn't like it. Maybe I had the wrong wildcard mask. I don't know. I was talking so damn much. I didn't know what the hell I was doing. 000.255, right? That should be the correct wildcard mask. And I was probably doing 0, 255, 255, 255. That's probably what I was doing. I don't know. I don't remember. Area 0 like that. And then we got a duplicate IP address. Let's go to this guy right here and fix that. And do a, did we remove, no, do, show. Oh, thanks, King. Appreciate that. Where was I at? Show, run. Let's see what we got over here. Showing up here. Section there. We needed to do just a 1.0. That should have became neighbors. I don't know why not. Let's do a no router. We did that already though. OSPF1, just to make sure. Oh, I put 11. Geez, now I'm really breaking things here now. Know this. Let's do a router OSPF1. Again. And say no network. So we're going to remove this network statement right here and put 1.0. Hopefully that fixes it. No network 192.168.1.48 000.15 area 0. That's weird because I did that initially and it didn't like it. I don't know why. 192.168.1.0. And it's that last octet we don't care about, right? So 000.255 like that. That's how I got to do it. Area 0. That should fix it all right there, right? I don't know why I didn't like it that first time. Loading the full there. P1R2, loading the full there. P1R3 is still down. He is still down. Let's take a look. Oh, there it is right there. It came up. It just came up right there. So now we look at show IP OSPF neighbor. Not network, but neighbor. And now we got a full neighbor right there. .17. So all these guys are neighbors right there. Those should be neighbors right there. We click the Gray Lab button and see if they like what we did so far. You can do Control G or just go to Gray Lab. And right there, you completed the lab successfully. So even though we made some more specific network statements and made them become neighbors, that's the reason why. I ain't gonna say that's the reason I don't like it. I'm over here promoting it, but saying why I don't like it. But I have constructive criticism about this application. They want us to fix something. When we fix it, they wanted it done their way, and they didn't even say how they wanted those network statements or anything like that. But then that'll be guiding your hand the whole way. So anyways, y'all hit that like button, hit that subscribe button. Make sure you're tuning into your boy Monday to Thursday, 8 p.m. Eastern Standard Time. Join that Discord server. We are following. I'm kind of half mic drop. Haphazardly or half following this study spreadsheet here. Where's that at? I believe it's right over here. No, I don't. I got it over here. Personal Cisco right there. So this study spreadsheet that I created in Google Docs, and I basically took the Encore. The topics from the Encore exam, and I put it in the spreadsheet and broke it down on where you can find it in the official cert guide. Like, for example, you read about FHRP and SSO, stateful switchover. You find that between pages 854 and I believe that's 889 right there. And so on and so forth, right? We have links to links to CBT Nuggets videos, but it'll tell you what CBT Nuggets, if you have a subscription to that, which ones you should watch. But some of them are kind of messed up because I had some YouTube links, and that was before I remembered, oh yeah, I got CBT Nuggets videos and stuff. So you could edit this spreadsheet however you want. But if you want a copy of it, just make sure you join my Discord server. We also have stuff from Boson Netsim, which we've covered today, obviously. So we did Ospf. So there was various labs for Ospf, right? Is that the Ospf line? Yeah, that's compare. Ospf is right over here, and there's various labs there, so I ain't gonna highlight it just yet. Whatever we covered, I put in the green, or whatever I streamed, I put in the green. There's also links for labs from gns3volt.com, so a great way to practice and stuff like that. This is kind of like the spreadsheet I'm kind of following and stuff like that. But anyways, if you want to copy it, make sure you join our Discord server. For now, comment, like, subscribe to the network.